Hey guys, hi, welcome to the session. So this is Padma Tejaswi and I have done my master's in chemical engineering from NIT Raoult. Yeah, so I think I sound perfect. I mean, you guys are visible, I'm visible, and you guys can hear, right? Yeah. So, how you guys doing? Hope you guys are doing well. And yeah, this is the last day of December. Means we are entering into a new year. And one more thing that we should worry is we are getting closer to our target, which means we are that Feb second is our gate exam for chemical engineering guys. Feb second is gate exam. So when I was writing this gate exam, when this new year occasion came, I was more worried about that we are more closer to our gate. So yeah, I hope you guys also have that same idea, right? But still, we should enjoy and at the same time, we should study also, right? Hello, Shahid. So, how are you? Okay. So, this class is about practice session. Like just before, we had a session regarding numericals on heat transfer and thermodynamics also. So now again, I just wanted to take a short session. So because last session there were few topics and there were few questions regarding this. So I just started another session. Yeah. So first of all, do you have any doubts regarding thermodynamics and all, or any subject from chemical engineering? So basically, if you have a plus subscription, then yeah, this is my profile name, Tejaswi Nuli. Okay, so if you search in Unacademy app, Tejaswi, you will get to my courses. So I have launched a few courses on thermodynamics part 1, 2, and 3. Right? So yeah, those who are having this plus subscription, they will have the benefit of courses. Yeah, thermodynamics only, the same thermodynamics. Complete course on thermodynamics part 1. So in three different topics, I have concentrated at different topics. Okay. So first part is all about basics of thermodynamics. What is first law, second law, third law, and what are adiabatic processes, isothermal process, and all about this. So, what if it is an adiabatic process? What is the heat produced or absorbed? So, I have concentrated on such topics because see, thermodynamics is like a very important subject for both chemical and mechanical engineering students. So, I was like, now even final year engineering final year students will be facing interviews, right? So I just wanted to help you guys with interviews. So yeah, I started a course on full thermodynamics, and it is all about basic parts. Okay. Yeah, and the second session is about solution thermodynamics. Okay. So in solution thermodynamics, we have excess Gibbs free energy, excess properties, residual properties, and Gibbs-Duhem equations, and yeah, multi-reaction stoichiometry. So all these, I have covered all these topics, and yeah, fundamental property relations, Maxwell's relations. So all of these topics I have covered in this part, and in third part, so this is exclusively for Carnot cycle. And so for heat engines, heat pumps, and refrigeration cycles, what are the different types of questions that we will be facing in GATE exam, like from previous year questions and like from interview questions? What type of questions we can face are the also I have concentrated on them. So if you want to check out the courses, then if you are a plus subscriber, then you can have access to this. Okay, and one more thing, which is an advantage for plus subscribers, is you will also have mock test series. Okay, so for GATE students, we have Unacademy have mock tests. So we also launched free mock tests. So if you have time, or yeah, it's not about time. You should practice actually. You should attempt a online exam at least once, because like just after going to the exam hall, it shouldn't be like a new thing to you, right? So you should get habituated to this, how to answer these questions and all. Okay, yeah. So let us solve few problems, and yeah, if you have any doubts regarding this topic or any other topic from thermodynamics, put your comment in the comment section, and yeah, I am here to reply you. Okay, yeah. So the partial molar enthalpy of species in a binary mixture is given by H1 bar. Okay, so H1 bar is equal to 2 minus 60 x2 square plus 100 x1 x2 square. Okay, so partial molar property is represented as H bar. So what do you mean by partial property? So partial property is nothing but differential of a molar property with respect to number of moles while maintaining constant temperature, pressure, and so we will be, if this is a solution, okay, means if there are more than two components and we are differentiating with respect to number of moles, okay, so if you are differentiating with respect to first component, then you should differentiate with this first component, maintaining all the other components concentration as constant. Okay, so along with the temperature and pressure. So this is called a partial property. Okay, so I guess you are clear now. Yeah, so we have H1 bar, and X1 and X2 are the mole fraction of species 1 and 2. So partial molar enthalpy rounded off to the first decimal place of species 1 at infinite dilution is. So we have an interesting topic, which is infinite dilution. So what do you mean by infinite dilution of species 1? What does that mean? So infinite dilution means diluting a particular component to a very high extent. Diluting a particular component. Okay, so let us suppose that we are having two components, x1 and x2. So mole fraction of first one is 0.01 and second one is 0.99. Okay, so we keep on diluting the first component, means we are adding more number of x2 and nothing like more number of second component is added, which is diluting or which is neglecting the presence of first component, right? So then what happens after a long time, its value will be very much lesser than, like, so when you compare this value with this, is this recognizable? No, right? So if they say that there is an infinite dilution of species 1, then it means that mole fraction of that particular component is 0. Okay, so this is a infinite dilution, and they want us to determine the partial molar enthalpy in kilojoules per mole of species 1 at infinite dilution. Okay, so when we calculate this thing, you should apply that delta H1 is equal to, I mean X1 is equal to 0. Okay, yeah. So let us write the, and let us start solving. So according to this, x1 is equal to 0. That implies x1 plus x2 is equal to 1. So from this we get x2 equal to 1, right? So we got x1 and x2 values. And we have h bar as given as, h bar is equal to 2 minus 60 x2 square plus 100 x1 x2 square, right? Yes. So this is the partial molar enthalpy. So how can we calculate enthalpy molar? I mean, okay, they just want us to determine the same partial molar enthalpy only. So this is a very easy question. Just substitute this x2 value and x1 value. Then what you'll be getting? H2 is equal to 2 minus 60 into 1 square plus 100 into 0. Right? So from this what you get? 2 minus 60 is equal to minus 58 kilojoules per mole. So this is the partial molar enthalpy at infinite dilution. Okay, so if they say that there is an infinite dilution of species 2, then x2 should be 0 and x1 should be 1. So at that time, what will be this h bar? H bar is equal to 2 minus 0 plus 0, which gives 2. So h bar is equal to 2 kilojoules per mole. If it is at infinite, this is x1 is equal to 0 and this is x2 equal to 0. Okay. So sometimes they also ask you to calculate molar enthalpy. So how we will calculate molar enthalpy with the partial molar enthalpy data? How can we calculate? So here we have to use Gibbs-Duhem equation. Okay. So if you want more information and so if you want to know the derivation and all the properties, the assumptions that we use in Gibbs-Duhem equation, log into the Unacademy app and select gate category for chemical engineering, and in that you'll be getting under Tejaswi Nuli, which is my profile. So in that you will be getting courses on thermodynamics. Okay, yeah. So this gives you an equation. From this equation, we get H is equal to sigma xi hi bar, means sigma xi h bar, which means x1 h1 bar plus x2 h2 bar. Okay. So from this you will be able to calculate the molar property or enthalpy. Okay. Yeah. So this is one of the model, and yeah, I guess you are clear with this. So any doubts regarding this? No doubts, right? Yeah. So let us get into next question. Okay. So we are having a binary liquid mixture of benzene and toluene. Okay. So these are two different components, and so it contains 20 mole percentage of benzene. Means this liquid mixture consists of 20 mole percentage of benzene. So it is indirectly giving about the information of mole fraction, right? So x1 is equal to 0.2, and see benzene should be 1 and toluene should be the second component. Yeah. So at 350 degrees Kelvin, the vapor pressures of pure benzene and pure toluene are, so P1 saturated is equal to 92 kilopascals and P2 saturated is equal to 35 kilopascals, or vapor pressures, okay, which is also equal to P1B equal to P2B. Okay, yeah. The mixture follows Raoult's law. They have given that information. All the information is given. Then it is a very easy question. Okay. So what we have to calculate here? The equilibrium vapor phase mole fraction. Yeah, the equilibrium vapor phase mole fraction rounded off to the second decimal place of benzene in contact with this liquid mixture at 350 degrees Kelvin is, means vapor phase mole fraction means Y1. So as they have given x1, x2 values, and this vapor pressures also, from this you have to calculate what is uh, vapor phase mole fraction, means Y1. Okay. So let us put the given data, what they have given. Okay. So x1 is equal to 0.2. That means x2 will be 1 minus x1, which is 0.8. And yeah, P1 vapor phase is equal to 92 kilopascals, and vapor pressure of second component is equal to 35. Is it 35? Yeah, 35. 35 kilopascals, right? Yeah. And okay, what is Raoult's law? See, here we shouldn't use modified Raoult's law because they have mentioned that we should use Raoult's law. So from that Raoult's law, what does Raoult's law define? YA into PA is equal to XA into, sorry, YA into P is equal to XA into PA of saturated or vapor pressure, right? So from this we get YA and at the same time YB into P is equal to XB into PBB, right? We don't know what is the total pressure in the system, right? So if you add these two, what you'll be getting? P into YA plus YB, which is equal to XAPAB plus XBPBB, right? So from this what you get? P is equal to XAPAB plus XB and PBB. Okay. So from this we got what is total pressure maintained by the system in terms of the known values, right? Means mole fraction and vapor pressures also. So from this, by using modified Raoult's law, YA can be given as PAV into XA by XAPAB plus XBPBB, right? So this is what they were asking about. The mole fraction of vapor phase mole fraction, which is in equilibrium with the component of benzene, right? So from this what we get? YA is equal to 92 kilopascal. So let it be in kilopascals only because as anyway this will be cancelled, right? So into 0.2 by 0.2 into 92 plus 0.8 into 35, right? So from this what we get? YA is equal to 0.396. So that means mole fraction of benzene which is in equilibrium with second component is 0.396. So similarly what is YB? Which is equal to 1 minus YA, which is equal to 1 minus 0.396. So from this we get 0.604. Okay. So yeah, these are the different questions. This is how you solve this problem. So while as I am explaining, I'm taking this time. But if you solve it, like if you are the person who is solving, then I guess you will be able to solve this question within 2 minutes, right? So yeah, and if you are quick in calculations and at the same time you should be um, faster in calculations and you should be accurate in your calculations also. Because see, they were asking like rounded off to the second decimal place means the answer will be correct only if you give exact answer. Okay, so they will not be range in such type of questions. So here what we had 0.396. So if you round off means you should cancel this 6 as this is greater than 5. So as is greater than 5, 1 plus 1 should be added to 9. So from this we get 0.40. So the mole fraction of this component A in which is in equilibrium with second component is 0.4. Okay. So if you give the answer as 0.40, then only your answer will be correct. But if you give 0.39, then your answer is wrong. Okay. So be careful with the calculations and yeah, do it properly. And yeah, you should be fast, but at the same time, you should check the calculations also, right? Because you have to be perfect, right? Yeah. So, any doubts regarding this question? So, this is a very easy question. I guess you will not be having any doubts. But still, if you have any doubts and if you are new to this topics, like just now you have started preparing for thermodynamics, then yeah, you can post your doubts in the comment section, and I will clear your doubts. Okay? Yeah. So we have an ideal gas which is adiabatically and irreversibly compressed from 3 bar and 300 Kelvin to 6 bar in a closed system. Okay, so we have an adiabatic process. So what is an adiabatic process? So here Q should be 0, means there will be no heat produced or no heat added to the system. And one more thing, the most important point, this that this is an irreversible process, right? So whatever we are calculating till now, and whatever the formulas that we are generating are for reversible processes. Okay, so if you forget this point and if you go on calculating, then your whole answer will be wrong. Okay, so as they have given irreversible, you should consider this property. Okay, so I will tell you how irreversible work and reversible work can be related. Okay, yeah. So the initial conditions, P1 is equal to 3 bar and T1 is equal to 300 Kelvin and P2 is equal to 6 bar. So what are they asking? The work required for the irreversible compression is 1.5 times the work that is required for reversible compression. They have given it. So, so when they have given it, why to worry, right? So work required in irreversible, work irreversible is equal to 1.5 times of work reversible. Okay? Yeah, and from the same initial temperature and pressure and to the same final pressure. So what are the conditions that we are maintaining in this process is the same for reversible process also. So we have specific heat capacity at constant volume, which is CV, is equal to 30 joules per mole Kelvin, and it is independent of temperature. So at the same time, they have given R value also, which is universal gas constant. Hello, Gupta. Welcome to the class. Yeah, we have R value and the ratio of molar heat capacities. So what does that mean? The ratio of molar heat capacities means Cp by Cv, which is 1.277. So this value is nothing but gamma. Okay. Yeah, we have this. And okay, so what does they need? The temperature in Kelvin scale. So they want the temperature in Kelvin scale and it should be rounded off to the first decimal place. Okay, of the gas at the final state in the irreversible compression case is. Okay, so what do we have here? So let us put the data that they have given. And yeah, so initially work irreversible is equal to 1.5 times of work reversible, right? And yeah, so this is an adiabatic process, right? So for an adiabatic process in a closed system, Q is equal to W plus E. Sorry, Q plus W is equal to E, which means W can be equal to E for the I mean for this adiabatic process, right? So in this process, we have work which is equal to the change in internal energy. So the change in internal energy, which is irreversible, equal to the 1.5 into change in internal energy of a reversible process, right? So we have this. This is the temperature in the final state in irreversible process we need, right? So which means Cv into T2 dash minus T1 for an irreversible process is equal to 1.5 into Cv into T2 minus T1 for a reversible process, right? Yeah, so we have written all the data and yeah, we need this value and CV is the same in for for both the cases, right? So we can cancel this. So T2 dash is equal to 1.5 into T2 minus T1 plus T1, right? So what does this mean? T2 means, so this is the temperature that is, this is the final temperature when we follow a reversible process. Okay, and T2 dash is the temperature, final temperature when we follow an irreversible process. So we know when we have a when we have a reversible adiabatic process, how to calculate the final temperature based on pressure, gamma, and temperature and volume, right? So what do we have? PV power gamma is equal to constant. So this is in terms of pressure and volume, but we have in terms of pressure and temperature. So this can be written as P into RT by P power gamma. So what does this mean? This means P power 1 minus gamma into T power gamma is equal to constant, right? So yeah, from this we get P1 by P2 to the whole power of 1 minus gamma by gamma is equal to T2 by T1. So in place of T2 by T1, in place of T2, we can substitute T1 into P1 by P2 whole power 1 minus gamma by gamma, right? So are you clear till now? Any doubts regarding this? So please post your comment if you have any doubts regarding this, because this is a very important problem. So such type of problems were there and before previous year questions also. Okay. So yeah, here we'll keep 1.5 into, in place of T2, T1 into P1 by P2 whole power gamma minus 1 by gamma minus T1 plus T1. Okay. Yeah. So from this we can write it T2 dash minus T1 is 300 Kelvin as they have mentioned in the problem, which is equal to 1.5 into 300 into P1 by P2, which is 6 by 3 whole power gamma minus 1 by gamma, means 1.277 minus 1 by 1.277, okay, minus 1 in minus 1, okay. So, okay, if it is a polytropic process, then in place of gamma, we'll keep n and the n value will be given. Okay, so the same formula and the process is also the same for an adiabatic process, and yeah, for this polytropic process, all the formulas are same. It's just that in place of gamma, we will keep n. Okay. Hi, Anand Kumar. Yeah. So we have. Okay. So just a minute. So from this we get the final temperature T2 dash is equal to 300 plus 1.5 into 300 into 2 power 0.277 by 1.277 minus 1. Okay. So this is how you solve this problem, and yeah, the temperature, the final temperature will be somewhere around 373 Kelvin, I guess. Yeah. So this is how you solve this problem. Okay. I guess this is a very interesting problem, right? So here we had irreversible process and at the same time reversible process also, right? And we are relating this with W work reversible is equal to 1.5 times of irreversible work. Okay. So be careful while doing the calculations and substituting the formulas. So if you find it confusing like keeping T2 dash, you can keep any T3 also, right? So yeah, again I will explain this question again. Okay. So as this is a adiabatic process, Q will be 0, and because of this work will be given as, can be given as change in internal energy. So change in internal energy, whether it is a reversible process or irreversible process, it is the same, right? Because it depends only on the initial and final states of the system, as this is a state function. Okay. Yeah. So we use the formula mcv delta t on both sides. So from this, as we don't know the final temperature in reversible process also, we just by using this adiabatic process, we calculate temperature T2 in terms of T1 and P1 and P2 and gamma. Okay. So this is how we solve this problem. Yeah. So if you like the session, give a big thumbs up, like it, and share it with your friends. And yeah, if you have any doubts regarding these topics, you can post your comment over here. And if you want more information regarding thermodynamics or heat transfer or mass transfer or CRE, which is chemical reaction engineering, yeah, you can go to the Unacademy app. So this is the app, Unacademy, and take the plus subscription. And yeah, if you are a new subscriber, then use this code Padma10. So you'll be getting a 10% discount on whatever you are paying. Okay. So if you started your preparation, I would refer you to start this. Okay. Yeah. You're welcome, Anil. Yeah. So for plus subscribers, we also have mock tests for GATE chemical for GATE students. Oh, you're new to this. Yeah, if you find this useful, then yeah, use this Unacademy app. And my profile name is Tejaswi Nuli. Okay. Yeah, so if you want to take subscription, then use this code Padma10. So you'll be getting a 10% discount on whatever the subscription that you take. Okay. So we have like 3 months and 12 months and yeah, single 1 month also is there, but I would prefer you guys to take this year-wise subscription, okay? So because you will be benefited on there if you take more long term, okay? Yeah. So I hope this session is useful for you, and yeah. So if you want to take it, use this code definitely to avail this discount. Okay? Thank you guys. So happy New Year, and yeah, prepare well for the GATE exam, and so yeah, enjoy your day. And one more thing, be careful. So don't party more. Okay? Yeah. Have a good day.